this diagram we can have. There's everything. Let me fill up a liquid. Before that, now the space between the slits and the screen, I'll fill up with a liquid of refractive index mu L or mu naught. I think we used earlier symbol. So let me write mu L. Any changes? Let lambda be the wavelength of light in air. It is. What is strict condition? Lambda is the wavelength of light in air. No. I want the position of central maxima. Or let me put one slab here. Straight away, let me ask that conditional question. Okay, this is the slab that is brought, and I want central maxima at the axis. And there's a liquid filled up. Please do think on this one. Let mu be the refractive index of slab. Mu L is the liquid. So here, let me write the condition. Where I want central maxima? If you want, I'll change it. Let it be at exactly opposite to slit S1. Shall I make some change? Or if you want next problem, I'll write it. No. We will cover more path before slits, the ray 2, then the ray 1, the path, and the ray 1 should cover more path after slit, but we do have something liquid. How to write this equation? I'll go back to basic rather than with the manipulation. So path difference delta x net, this should be equal to. So first path difference after slit. So how do we write S2P? Because the ray is covering S2P distance where in liquid. So optical path length, how much it will be like a mu L S2P. Then mu L S1P. S1P minus PP, I think I'm able to show it. Yeah, I'll write it here. S1P minus T is what the path covered in liquid. Optical path length, mu L S1P, that one. So this everything bracket. Yeah. Please do notice that this is very important. Huh? Then remaining path where it will cover, it will cover in slab, no? So what we should write? How much of length it will cover in the slab? T. Then what is optical path length? Mu T. So shall I write plus or minus mu T? Plus mu T. Or mu LT. This is very important. Rest all mathematics. I'm telling this one. This is only the concept. I'll put once again. I'll put once again. I had to come after slits also. There's a before slit. First like after slit. S2P. The ray will cover a path length of S2P in liquid. Optical path length mu L S2P minus. The ray will cover a path in liquid. How much? S1P minus T. In liquid, optical path length mu L S1P plus the ray will cover a distance T in slab. Optical path length mu T. This is what after slits. Before slits, minus of, before slits, the minus of. The brackets plays very important role. What we have the brackets here. Okay, this will be the, now what shall I write? This shall we write only equal to d sine alpha? I think we have discussed enough problems, no, earlier. I'll write one step so that it will be next one. Mu L S1P plus mu mu L and check once the equations, and delta x2, what you can write it as d sine alpha. Check once the mathematics here. Mu L S2P minus mu L S1P. Mu L we took common. Then minus of mu plus mu L. So mu minus mu L T, that is. So this is it. So now we'll, what is S2P minus S1P? Should be 0, no? Because we know that from the geometry you check it. What is S2P and S1P? S2P is in fact equal to S1P. So therefore this should be equal to delta x net. Path difference should be 0. There's one more condition because the rays will undergo superposition at center of mass where the path difference should be 0. This should be equal to mu L 0 T minus d sine alpha. So this will become T is equal to d sine alpha mu minus mu L. Check once all the conditions. Okay, fine. So these are some ways of writing the equations, like the beam of light will illuminate the slit at an angle alpha with axis. Then I'll fill up some liquid between the slit and screen. Then what should be the thickness of slab and where I should place, so the central maximum must be here. Now let me ask question. I want order of interference opposite to slit S1 here in this problem. Or I want central maxima exactly opposite to slit S1. Central maxima, I want it to be here. Capital D it is. Huh? Oh, sorry. This is one. Huh? Yeah, I'll make changes, ma. Okay, S1, S2, I'll write it here. Yeah, it should be small d. Capital D, and this one is the small d. I made some changes. Please do notice, all of you. Okay, why only central maximum? So shall we bring some situation where the central maximum must be here? Exactly at slit S1, the central maximum must be here. For that, what conditions you are going to put? So same thing, the ray of light will illuminate the slit at an angle. The same diagram. Let me take the next condition. Somebody mute it. No. What is the condition I'm putting is like, I don't know where to, so how to bring exactly central maxima exactly opposite to slit S1. It can be like this. Huh? There can be a situation of like this also. Please, all of you mute it. No, a lot of disturbance will come. Okay, immediately what happened? What will be the conditions? Please try to mute it. Huh? Okay, no, directly I think first you go to the pen, paper, and why the red color? Where the central maxima exactly opposite to. Okay, I think before this, a student must have a background. What is that? If the ray comes illuminated in this way, where we are here, where the central maxima is, will be below axis, no? If the ray is incident at an angle alpha, where it will make an angle alpha with the axis in this direction. Now, where the central maxima will not be above the axis, will be below axis. Now, what we should do? It should, the central maxima should be shifted up. It should be brought exactly opposite to slit S1. Getting the idea? I think this is a background we needed. So what I should do, I should shift the pattern up, no? So to shift the pattern up, what shall I do now? Where I should put a slab? Shall I put slab here or shall I put slab here? Anybody? Please reply. There's a very nice conditions is what I'm bringing for students to really analyze here. Huh? Hey, test one. Okay, fine. Yeah. Okay, Sai Surya, good. I'm going to put slab here to shift. And moreover, there's the liquid is there. So what is the condition of the whole pattern has to be shifted up such that the central maxima should lie here. This was the idea. Okay, got this. I think make observation. The same question is just being asked here. So now what is the strict condition? The pattern. Okay, I think we are here. The pattern must be here. So definitely the slab has to be brought it here. Okay, right equation, right equation. This will be T. This will be mu. This is S1, S2. So we'll do one thing. We'll write the set of equations. then what happened? We'll come to this one. Let's not bother about the getting answer now. We'll write as usual our equation. Net path difference equal to path difference of the rays after slits, then path difference of the rays before slits. So that should be equal to n lambda. There what happened? YCM center of it should be there. So what should be the thickness of slab? So that the path difference. What happened? This is. I'll set right things. Just give some time. I think okay, fine. Huh? There's a liquid. We'll bring the slab here. Carry on the. I forgot all the shortcuts, so there's a major problem. Write some equation I want you to write. Huh? I'll come into picture. Let me have water. Meanwhile, you try it. Huh? Let me proceed with the mathematics. The path difference delta x net should be equal to mu L S2P then mu L S1P minus T plus mu T. So there's a thing, and before slits, it is the same equation. So they should be before slits. It should be like a plus delta x2 or minus delta x2. I think the ray 2 will cover more path before slits, and the ray 2 will cover more path after slits also. We are assuming it to be here. So this will be the equation. So now this should be equal to, further one more step, mu L S2P minus S1P minus of mu L T plus small d sine alpha. I think I'm right, small d sine alpha. This S2P minus S1P will become sine theta. This theta, let me indicate here. Okay, some of you are asking, sir, what is theta? Let me show that this is theta. And this is what our alpha, no? So mu L d sine theta no delta x net. So I'm interested in the position of maxima. So n lambda equal to mu L. Next step, I'll write it. Tan theta mu minus mu L t plus d sine alpha. Mu L tan theta will be small d dy by capital D. This should be good. So, sir, from tan theta y by d, how you wrote? This is what that y. And you make it one more. See, we have to be very alert. That's all. So looking at this triangle, what is tan theta? Y by capital D. I think by this term, you know, sir, y sin theta has become tan theta because of condition d very much greater than small t. Theta very small, sin theta will become tan theta, and tan theta will be y by capital D. Just stick on to the basics. Almost the same thing is getting repeated. So now we have everything. So what is lambda? Lambda is the wavelength of light in here. So this should be equal to. So let's go for now expression for y. So y equal to n lambda capital D by mu L small d plus mu minus mu L by mu L capital D by small d minus d sine alpha. T is not there. Huh? Okay, here T is not there. Okay, I have brought, so we are searching for position of maximas. Let it be y max. Okay, no, I want central maxima. Where the central maxima should be exactly at the center of opposite to slit S1. So what shall I write y? Y should be equal to small d by 2 and n should be 0. And the n what pen n should be made 0. This should be small d by 2. Then we'll solve for it. We'll get the thickness of slab. What should be the thickness of slab? They may ask you questions of these kind also. You have to be ready. You check the advanced paper, questions of these kind are also available. So what should be the thickness of slab? Now we'll generalize it. Find thickness of slab so that central maxima will be exactly opposite to slit S1 on screen. What shall we do? So this y max should be equal to d by 2 and n should be 0. That we have to substitute in above equation. So substituting that, d by 2, 0, mu by mu L minus 1 t capital D by small d minus d sine alpha. Then this will become solving for t, will get the required answer. Let me put it here. So this t will be d square 2d check it once. I think the final equation check once. D square by 2 2d mu minus L d sine alpha. Okay, I think this will be our final answer. Okay, like this should be the thickness of slab. They asked questions of these kind also. Just be alert. That's why I just brought this condition. Okay, what is the best thing a student has to focus? So let me show the complete picture of the, have a glance of the total numerical. See once here. This is the something I feel a student has to put effort here. Here is what the thing. Once you know this, okay, fine, everything you can manage. Or the next step. Let's see, anybody, any? Why n equal to 0? Because central maxima, order of interference of central maxima should be n equal to 0, no? Because what is the path difference of the rays arriving at central maxima? Should be 0. Delta x should be 0. Okay, therefore n I should write. Where central maxima will lie on the screen, where the path difference of the rays emerging from emitted by slit S1, S2, if it is equal to 0 on arrival at that particular point will be central maxima. So therefore, to locate central maxima, n must be substituted 0. I think that this is a very primary question. May look simple, but I think a lot of concept is involved. So which point on a screen will be central maxima, where the path difference, net path difference of the rays arriving there is 0. That point will be central maxima. This is okay. Tell this 1000 times, that is enough. Oh, I don't. Can you hear me?
Yes, sir.
Okay, so connectivity was problem. Somebody was asking. Yeah.
In Weimar's equation, it is d sine alpha by mu L, sir.
Let me check. Okay, this mu L should also go for this one, no? Simplification.
Yes, sir.
One mu L will come here. I think I missed it. Small d, capital D. Oh, one mu L will be here. Yeah, okay. So here also one mu L will be there. Okay, I'll make changes, ma. Okay, I'll make it changes. So here also one mu L will be there. One mu L. Okay, fine. Yeah, thank you. This one. Okay, this mu L is what I missed it. Check once the calculation part. Here mu L, here one mu L. Okay, mu L. Okay, this mu L, here mu L. Mu L will be there. And finally, yeah. Or mu minus mu L we could have written. Okay, let it be, yeah. This one. Okay, this one will be the, yeah. I'll scroll down. If you have anything, you can ask it here. Let me take the next condition.